Wait, you are given an array of integer stones where stone I value is the weight of the I stone. We are playing a game with stones. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y with x less than or equal to y. The result of this smash is if x and y are equal, both stones are destroyed. If y is not equal to x, the stone of x is destroyed and the stone of y has new weight x, which is y minus x. So now, if these two stones are not equals to the same values, x will be subtracted from y, and that will be our y value now, which will be added back to the stone. So at the end of the game, there is almost one stone left to return the weight of the last remaining stone. If there's no stone left, return -1. So let's copy this. This will be our return statement to return. So we put that in there so that we can keep that in mind. So let's also note these ones down so that we can have them in mind. And also this one over here. So now at the end of the game, there should be a list. There should be almost one stone left. So this one also is important. So now let's look into our examples. So if we have this stones list, and we choose the two biggest numbers, boom and boom, largest numbers, heaviest numbers as shown over here. So 7 and 8, and we since these two are not equal as shown over here, they're not equal. That's y minus x. Y, remember, is our largest number. So y minus 7 is 1. So we have 1, and then we put 1 back into it. Our next two largest value are 2 and 4. 2 and 4. So now since they're not equal, we subtract x. 4 minus 2, and we get 2, and we add them back together, and so on until we get 1. So how will we do this? We'll use a heap. We'll use a heap to solve this problem, since Python doesn't have a Max-Heap module. Our heap is min heap. We have to negate our values. So I'll get into this soon on how we will do this. So let's negate our values. Let's name it Max-Heap. Max-Heap equals to our list. So for every stone in our list, for stones, and stones list. So negative every stone in our stones. So let's heapify this. Heapify negate all values in list, stone list. Heapify is now we've now heapified our max value. no Max-Heap. Now we have a Max-Heap to pop our largest numbers from efficiently. At a large time. So, hold on. Our heap. This is O of n to turn here. Turn list into here. So now we have O of n, and so now we'll be able to do these operations that we're about to do below at O of n time, log n time. This is O of n. So now let's look at this case over here that we have to pay attention to. So while our length of our Max-Heap is greater than 1, let's do this. While our length of Max-Heap is greater than 1, let's pop the values out and turn them back to positive. So heap pop y will be our largest number. Negative. So pop largest value out and convert it to a positive value. And now our next value heap dot this one could be equal to or the same or less than y. Pop our next large equals to y and convert it to positive value. Pop our next largest value or equal to y. So now we'll pop these values and turn them into positive numbers. So if both of these are equal, we just leave them out. There's no need to put them back. But if they're not equal to this, let's pop them back into, let's push them back to the list after turning them back negative, which will be heap dot heap push our max, our list, our heap list, heap, max heap, and then turn it back to negative, and then y. Y comes first, -1. Or we forgot to make our if statement if y is not equals to x is not equals to y, and then this, and then so now if it's not equals to this, we subtract, we push it back to the max heap and then turn it back into positive. Push it back to max heap. After turning it back to a negative. So now, so now we have this case to return, to take care of, which is going to be return. It's turning back into a positive, but turn our value to a positive, negative heap goes to 0. If we have a max heap, else 0. So this should work perfectly. Length of negative plus 1 less than for stone and stones. Let's debug our code, check if there's any syntax mistakes. Turn this into a negative, positive. X is not equals to y. Push it there. Return a statement. So let's learn it and see if it works. Hopefully it works. We run it, but there is a mistake already. Unexpected indent. Unexpected indent. And that's it. It was an extra space in it. Y is not defined there. Oh, sorry. X, sorry. Should be equals to X. This will cost to max hit apart from max. Let's go here. Max, let's go heap. And that's it for this one. So our time complexity is, so here our time complexity of, so popping values and pushing them into pop and push values will be done at a log of n, and our heapifying it will be heapifying list will be O of n. So that will be time complexity is n of log plus n. log n plus the n over here. Max heap will be done at the log of n, and then if you find the list will be an n added to it, so n of log n, which is not bad at all. And our space complexity is O of n.